Docker is one of the most important tools for every programmer, data scientist, and machine learning engineer. Knowing how to build applications, how to train machine learning models, and how to visualize data in the front end is great, but if you don't know how to actually deliver your results to the customers, be it as an employee, as a freelancer, or when developing a SaaS product, you will fail to deliver any value. You cannot really provide any value. Deployment is the final key step in the process, and Docker is essential for it. This video today will be a complete Docker crash course for beginners. We're going to cover the theoretical basics like what Docker is, when to use it, what containers are, what's the difference between a container and a virtual machine. We're going to also cover practical basics like images, containers, how to create images, how to pull images, how to work with volumes, how to write Dockerfiles. And then we're even going to cover Docker Compose, which is going to allow us to let multiple containers work together. All of this will be illustrated with practical examples. So we're not just going to cover how to do things theoretically, we're actually going to do it. We're actually going to write the Docker files and the Docker Compose files so that we can see how this works in practice. If you like these videos, I would really appreciate it if you hit the like button and subscribe to this channel to make more free videos like this one possible in the future. But now, let us get right into it. Alright, so we're going to learn Docker in this video today, and the goal of this crash course is to optimize for speed and simplicity. So this is the best video, I would say, to get started with Docker as a beginner, to get a big picture understanding, to get a quick introduction. We're going to cover as many things as possible in as little time as possible, but it's not the best tutorial to learn Docker in depth. So we're not going to go into all the details for every single concept and every single command. It's more about covering a lot, understanding what Docker is, how it works, when to use it, learning basic commands, learning how to use Docker Desktop, understanding the purpose behind Docker, and then also in the end learning Docker Compose on a high level, on a basic level. And then you can take it from there and learn Docker in more detail, in more depth. This video is more like a jumpstart crash course to get you started if you don't know about Docker at all. It's just a big picture understanding starting point, I would say. So I want to get started right away by briefly talking about what Docker is, when to use it, and why to use it. So Docker, in a nutshell, I would say is a platform, an open source platform for containerization of applications. Now, what happens when we want to deploy an application is we have to go to the server. So let's say we're developing the application locally on our system. We have a database, we have a front end, we have a back end. Maybe we have Fast API and React and a Postgres database. And everything runs locally on our system, and now we need to put it, or we need to deploy it onto a server. So it has to work on the server as well. Now, one way to do it is to just take all the files, upload them to the server, install all the dependencies, set up everything properly, create the database, create the users and so on, and then just run the application on the server and hope everything works. Now, the problem with that approach is that it takes time and it's prone to errors because, of course, different environments, different systems can have different dependencies, different commands, slightly different configurations can have slightly different problems. And it's just oftentimes quite a pain to have to do everything again that you already did locally, to not have it work on the system that you want to deploy to. And it's just a lot of effort that has to be put into that to make it work. And as I said, it's prone to errors. The idea of containers now is that you package everything that you need to run the application. You package all of this into a container, into an isolated unit. This container has all the libraries, all the binaries, all the config files, all the source code, even the operating system basically in it, and you can just run it as an isolated unit. So everything you need is in there, which means if I have Docker on my system and you send me a Docker image that I can use to create a Docker container of your application, and it's running on a bunch of different technologies that I don't have on my system, I can still run your application because all I have to do is I have to create a Docker container and everything is in it. I don't need to install any dependencies whatsoever on my system. That's the main use case for containerization. This is what Docker basically does. So we take applications like a front end, a back end, and the Postgres database. With Docker Compose, we can also combine them into by using 3 different images, for example, and making them work together. We're going to take a look at that at the end of this video. But the basic idea is we have these isolated containers where everything is packaged into them. Now, just a very, very brief explanation of how this works and what the difference between that and a virtual machine is. I'm going to use that image here. I have some Google images that are that have a commercial license. So I'm going to just open this in a new tab. And this is not, my graphic or anything. It's just a simple illustration. What you have in a virtual machine is you have a server, a host operating system, and then a hypervisor. And a virtual machine has its own operating system. So you have this guest operating system, you have the binaries and the libraries, and you have your application running. Whereas in a container, what you're doing is you have the physical server, you have the host operating system, then you have something called the container engine, so the Docker engine, and then you have no guest operating system, which means the containers are using the same kernel as the host operating system, which makes the containers more lightweight, so faster, and also smaller. That's the basic, in a nutshell, idea here. You can research the architecture a bit more. And what I want to do now is I want to show you how to install Docker. Now, I have Docker already on my system, which is why I'm not going to install it myself, but the installation is quite simple. You have two ways to install Docker, and you're going to need both of them if you want to deploy to a server. One is you want to install Docker Desktop on your desktop operating system. That's just the easy way to work with Docker with a graphical user interface. The second thing is you want to install just the Docker command line, just the Docker engine, which is useful for the server that maybe doesn't have a graphical user interface. So go to docker.com, go to download Docker Desktop, go to download for Linux or whatever your operating system is, and just download the respective package. So for example, I'm on Pop! OS. This is Ubuntu based. I click on Ubuntu. I go to this Debian package or dep package here. Click on it, download it, sudo apt-get install, dep file, and that's basically it. You install Docker Desktop. Now, you can also go to the Docker documentation for installing the engine. Just again, go to your operating system, Ubuntu, and in this case, again, it's quite simple. You scroll down to this here, you execute these commands. This is going to add certificates and curl from a repository here. And then you just have to install the respective tools here, Docker CE, Docker CLI, and so on. And then you have it in the command line. So that's how you install it. Quite simple. I'm sure you can get it done for your respective operating system. On Windows and Mac, you also have Docker Desktop. That's the easiest way to work with it. Now, if you have a normal desktop environment on Windows, on Mac, on Linux, GNOME, or something like that, if you're a normal person, in other words, you can just go and type in your search bar Docker Desktop. You're going to see the application. If you are a crack developer, like I am one, you have to run a special command. So I'm using i3 here, a tiling window manager, and because of that, in D menu, I don't have an entry by default. I have to run this command here, systemctl user, so -- user start docker - desktop service. This is just because I don't have an icon. I don't have anything I can click. So if I want to start Docker Desktop, this is the command I have to run. But most of you guys, you just have to type Docker Desktop somewhere and you're going to find the application. So what I have down here now in my polybar is Docker Desktop running. You can see here that this is what it looks like. Let me use full screen here. And the basic idea is you have containers, you have images, and you have volumes. And the idea of images is that there are a blueprint for containers. So the image is a recipe, a blueprint, a template, you could say, instructions on how to build containers, what has to be done for this container to be built and then run. The container itself is the isolated unit. So the container itself is the thing that contains your application, that runs your application. And volumes are just persistent. Let me delete this one. Volumes are just persistent data storage. So what I have here is I have Ollama Web UI. This is not relevant for this tutorial. It's just something I use on my system here. This is a tool that allows you to use large language models on your system. So Ollama, a lot of you guys know it. Web UI is a web user interface for that. I pulled the image from this source here. So I pulled the Ollama Web UI image, and then I ran a container, Ollama Web UI. Now this is running locally here in the browser. You can see on my system, and I don't have to have any of the dependencies installed on my system. It's all in that container. So even if I don't have Python or anything installed, this will still run because it's all in the container. Now, what's important to understand here is that there's something called Docker Hub. Now, Docker Hub is a so-called registry. So we have this registry here, Docker Hub. There's also other registries. There's one from GitHub, I think, from Amazon. You can also have a self-hosted registry. And the idea is you have these images here that you can pull from Docker Hub onto your system. So for example, if I want to use Python, if I want to use Nginx, if I want to use anything, of these packages here, I can just pull them onto my system. I don't need to install anything. I just have to pull the image and I can run it as a container and use it. Now, it doesn't make necessarily sense for everything, but you can do it like that. And it also makes a lot of sense if you want to use Docker Compose. For example, instead of using Postgres in some fancy way, I can just use a Postgres image to run a Postgres database. So I can use one from Docker Hub here. The important thing you need to know is that Docker Hub is the default registry. So whenever you pull something with Docker, you're going to get it from Docker Hub. You can think of this to be a little bit like Hugging Face or GitHub, where people can upload stuff and you can pull stuff, so you can download models. In Hugging Face, it's models, and here you can download images that can be turned into containers. So let's actually do that right away. So let me put that onto my second screen, and then I'm going to open up a command line. I also want to have the Docker desktop side by side so you can see what's happening here. I'm going to go to my images, and here now I'm going to run the following command. I'm going to say docker pull and then the name of an image. And there's one image that is used as an example here, oftentimes called Hello World. This is just an image from Docker Hub that prints a message, nothing too fancy about it. And when I say docker pull Hello World, this is going to, first of all, ask me for authentication here. Not sure if it's going to do that for you as well. But basically, this pulls now the image Hello World onto my system from Docker Hub. So I have this image Hello World now. And when I go to containers, I have no container here. But when I do docker run hello-world, what's going to happen is it's going to take that image, build the container, execute the associated command, and then stop the container again. So I can run this. You can see this is the message that this particular container produces. I have this container now with an automatic name, and the status is exited. Now, one thing that you will notice is every time I run this, it creates a new container. If I don't like that behavior, or if I want to delete the containers that are no longer used, I can just say docker run, but I can provide the --rm flag, which is going to allow me, or not allow me, but it's going to delete the container when it's no longer needed, as you can see. Makes sense if you have something like this. We can also try something else. I can do docker run Python, for example. And the cool thing about the run command is if I try to run something where I don't have the image, so if I don't have a Python image here, it's going to say unable to find the image. I'm going to have to pull it from Docker Hub. So I can also omit the pull command. I can just say docker run Python, and it's going to pull and run the Python image. So it's going to pull the Python image and it's going to run the container. I can also specify here a tag. So I can say Python version 3.12. So I can do that with a colon, Python 3.12, and then I can say -slim, for example. There's a bunch of different versions, a bunch of different tags. You can look them up in Docker Hub. But essentially, this means I want to have the Python image that contains version 3.12. And slim basically means it's a more lightweight version. The operating system that is used is more lightweight. The whole image is just smaller. So when I run this, this is going to say unable to find image locally, pulling, and then you can see I have the image. It's being run as a container here as well. The thing is now the Python image doesn't have a command associated with it. So I have the image, I can run it, but it doesn't do anything. However, I can still use it. So I can still say docker run --rm Python 3.12 slim. And then I can say, for example, Python, I can use that command Python from the container now, even if I don't have Python installed on my system. And I can say -c, for example, to say print hello world. And this will execute the code here in the container. So that would be a simple example of that. Now, the interesting thing here, maybe I want to show you that right away, is that there is something called layers in Docker, which means, and this is going to be something that we understand better when we write Docker files ourselves, but these images now are based on other images. This Python image here, this Python 3.12 slim image, has layers to it. So layers means there is already a package, also from Docker Hub, called Debian 12 slim. This is Debian. Debian has a certain layer associated with it. This is already an image. From this image, I built more stuff. I have these commands here that extend the Debian image to make it the Python image. And now we can take another package that takes from the Python image and extends it. This would just append more layers. We're going to talk about that more when we get to Dockerfiles, but that's something interesting to understand. that images can be based on other images and that the Python image is based on the Debian image. So the Python 3.12 Slim image is based on the Debian 12 Slim image. This is important to understand. Now, I want to show you a couple of commands here because we're working with the UI all the time. So let's go and let's say we're on the server and we want to see what kind of images we have. We can do that in the command line as well. We can do that by saying docker image ls. This is going to display all the images. Let me zoom out a little bit here. You can see Python, hello world, and my Ollama here. By doing that, I can do the same thing as just clicking on images here. How do I do that with the containers? Quite easily, I can say docker ps. This is going to show me all my containers, or actually it's going to show me only my running containers. So for example, let me run now docker run. I'm going to use busybox now. Busybox is a binary that contains Unix tools, minimalistic Unix toolkit, basically. So I can say run busybox. I can detach it, so I can do -d to run it in the background. So -d busybox, and then I can run a command sleep 3600. This is just going to keep it running. And now you can see I have this running, just a basic toolkit. Doesn't really matter what it does, but I have this busybox running, and I can also just run it without a sleep command, which is going to exit immediately. Now, if I run docker ps, I'm going to only see the running ones, so only the running instances here. Maybe let me open this up here as full screen. You can see I have, maybe let me clear the monitor here. Let me clear the command line here. But you can see busybox here is running with the command sleep. But if I say docker ps -a, I can also see the one that is exited. So that's also important to understand, that when you do docker ps, you only see the active containers. All right, what else can we do? We can look at the logs. We can do that here in the container. So I can go to the Ollama web UI, for example, and go to the logs tab. This is going to show me what's happening here. I can also do that in the command line by doing docker logs. The important thing is I need to do the docker ps command first, because I need to be able to target the container. I can either do that with the container ID, so either with this thing here by copying it to the clipboard and pasting it here, or I can use the name. So here, let's go with the identifier, docker logs, and then this is going to show me the logs in the command line as well. What else can we do? We can stop. We can do docker stop to stop a container. So for example, docker stop, I can copy this here. This is going to stop the container that is associated with busybox here. Probably takes some time to do that. But once it's done, this container is going to be stopped. There you go. And what I can also do is I can remove all the containers that are no longer used by using docker container prune. This is going to essentially remove all the stop containers. This is just easier than checking them off manually here, or easier than doing it manually in the command line. Just docker container prune removes all of the containers that are no longer used or that are no longer running. But what's very interesting here is, in my opinion, that we can also interact with the environment. So for example, if I have busybox running, I can actually go into the operating system, because all this is running on an operating system. We don't just have Python running nowhere. Python is running on Debian. Busybox is running in its own operating system. Ollama is also running on something. Maybe we can see that here in the image. I'm not sure what they're using here, or if they're building from. Yeah, so you can see Ollama web UI is building on Python 3.11 Slim, which is building on Debian, which means I can go now into the container that is running, the Ollama container, or maybe so that you can follow along. Let's do that with a busybox instance here, docker run -d busybox sleep 3600. What I can do now is I can click on this container. I can go to terminal, and now I'm in the system. So I'm actually in the command line. I can just do ls. I can see what this system looks like. It's a basic Unix system. And I can, for example, create a directory data, and I can go to that directory data, and I can maybe create a test.txt file, and I can do hello world here, and I can save this, and I can quit, and that's basically it. Now I can also in Docker desktop go to the files. I can explore this here in a file explorer like this. I can also save and edit the file here in the UI, but I can also do the same thing in the command line. How do I do that in the command line? I just have to say docker exec and then -it for interactive and TTY. And then I have to provide the container identifier like that. And then I can specify what exactly I want to run. And in this case here, I want to run /bin/sh to get a shell in my command line. And here now you can see I'm in that Docker container. Inside of it, I can go to data and I can cat the test.txt file. You can see hello world. So that is how you can also do that in the command line. I can then exit, and that's basically it. Which now brings me to the next point, which is quite interesting. How do we actually work with files that I want to keep persistent over different runs? So let's say now we created this file with the hello world in it, the test.txt file. What if I now go and delete this container? So I delete the container, and then maybe I run it again. I create another instance of it. So somehow I cannot access my commands. Let's see. Docker run -d busybox sleep 3600. Now I have a new container. I can go into it. I can go to the terminal, and now I can see I don't have the data directory anymore. So how can I actually get persistent storage? How can I save files and keep them saved? And the next time I have a container, I want to access the same files. If I want to do that in Docker, I have to use volumes. So volumes are what we use to have persistent storage. Volumes are what allows us to save data, keep it there, and then use it with the next container if it's not the same container, right? So I can delete this here. And what we're going to do now is we're going to create a Docker volume. I'm going to say here in the command line, Docker volume create, and let's call this test volume here. This is going to create now a Docker volume test volume. And all I have to do now is I have to run the same command as before. So run d busybox sleep, but I'm now going to also say -v for volume. And I'm going to say that I want to map a certain Docker volume to a certain directory in this busybox instance. So I want to map test volume, so test volume, and then :/data, for example. What this is going to do is it's going to mount the Docker volume test volume at the path /data in this container. So I can go into it here again in the terminal. I'm going to use the Docker desktop UI here. It's easier. And you can see I have the data directory. So I can go into it. Nothing is here. But if I now go ahead and say test.txt again, I say hello world, I save this, and I exit. Or actually, I don't need to exit. But basically, if I have this now here, I can also delete this container. So it's stopped and deleted, but the volume is still there. So I can still go to the volume. I can still click on test volume. I can go to data here, and you can see I have this test.txt file, which I can also right click and save as. I can also delete it here. But the cool thing now is I can just run the same command, and it will open up a new container. I can go to terminal. I can go to the data directory, and you're going to see now that I have the test.txt file in here, even though it's a new container, even though the old one was deleted, just because the volume is still there and is now mounted at data. And of course, I can do that with different paths as well. So I can say not data, but for example, other path. And I can run this, and now I have my new instance here. I can go to terminal, and now I can go to other path, and here now I have my test.txt file. And the same volume can of course be used by multiple containers. So you can actually see that when I go to the volume, you can see in use what kind of containers are using this specific volume, so they can exchange data through the volumes as well. So it has multiple use cases. Another thing that we can do if we don't want to use Docker volumes, which I would recommend you use Docker volumes in production and when you actually do the work professionally, but maybe for playing around, you want to use your own volumes. So you, or not your own volumes. You want to keep the files on your own file system. So for this, let me navigate to my working directory. Let me remove everything from here. And let's now create a directory here, call it test.dir, for example. And in this test directory here, nothing is in it. What I can do now as well is I can run the same command as before, but instead of saying test volume here, I can say test directory, but to specify that this is not a volume, but an actual directory, I have to either specify the full path or I have to say /test directory. So what this is going to do is it's going to create a container, and the container is also going to have, in this case now, other path, not data, but it's going to have this other path directory. And here I can create a file test.txt, hello world, save it, close it, and delete the container. And this is now going to be in my test directory. So I have this file now on my file system, which of course has security problems, which of course is not professional. It's not really recommended to do it that way unless you want to play around with it. So the proper way is to use Docker volumes, but you can use this one as well if you just want to play around a little bit or test stuff, or if you have a specific reason for it, if you know what you're doing, of course. So that's an alternative way to do that. You specify your directory with a path instead of a Docker volume. So now we're going to move on to the more interesting part of this course, which is about containerizing our own applications. So Docker is not just about pulling images from Docker Hub and using what other people have created. It is about writing Dockerfiles and containerizing our own applications so we can deploy them easily to servers and other systems without worrying about dependencies and compatibility issues. So for this, I have created a simple Flask application, which we're going to use as an example here. It's a very minimalistic example. We have an app.py file. And what we do here is we basically just specify the path to a log file. We have either the default value message log.txt, or we also have the possibility to overwrite this by using the environment variable here, log file. The only reason I do it like this is to show you a command in the Docker file or a statement that allows us to set environment variables. I wanted to show you how to do that. Same thing is done for the port, 5000 by default port. The environment variable can overwrite this, and debug and false have the same idea behind them. So what this application does is it has a single endpoint. This endpoint takes get and post requests, and in the case of a post request, we get the message from the user and append it to the log file. Nothing too complicated, and in both cases, get and post, we then take all the messages and we split them on line breaks, and then we just render them into an HTML file, and in this HTML file, these messages are displayed as an unordered list. So nothing too complicated, and we can actually go ahead and run this to see how it works without containerization. So I can just say Python 3 and then app.py. I can open this in the browser, and it's a very simple application. I can just type some stuff, send messages, and all of these messages are added here to the list. So that's basically it. We can also take a look at the log file here. This is what it looks like. And this is our very, very minimalistic Flask application that we're going to Dockerize. So how are we going to do that step by step? First of all, when you develop an application, it's best practice, if it's a Python application, to create a so-called virtual environment. So you don't just want to be working on your system Python version. You want to create a virtual environment where you only install packages that are going to be relevant to that project. And in this case, I actually have something like this already. So I have a venv, a virtual environment called .venv. So I have this directory here, .venv, and in it, there is the Python version that I'm using for this project. So what I'm going to do now is I'm going to say source.venv bin activate. This is just going to activate the environment, as you can see here. And now the Python version, if I say which Python 3, you can see that the Python I'm using is part of venv. That's basically the idea here, or actually now I'm using the virtual environment in my prepared directory because I copied the folder, but you get the idea. It's the virtual environment associated with that project. And one thing that I'm going to need for the Docker container is I need a requirements.txt file. I need to know what kind of Python packages I need to install because I'm not going to take the environment and add it to the Docker container. So I'm going to say here Python 3 freeze. Of course, what I mean is pip3 freeze, the package manager, because this is going to show me here all the dependencies, all the versions of the packages that I have installed. And all I have to do now is I have to say pip3 freeze and feed that into a requirements.txt file. So that file is going to be put into the container. We're going to use that to install all the dependencies, and then we're going to copy the rest of the files, and we're going to have our application in the container. So now in order to define how our image shall be built, we're going to write a so-called Dockerfile. So Dockerfile is written with an uppercase D like this. And in this file, we're going to include instructions on how to build the image and how the container should behave when started. So in this file, we're going to define environment variables. We're going to define a base image that we want to use. We're going to copy files. We're going to run commands. We're going to expose ports, at least for documentation purposes. We're going to set the command that shall be executed when the container is running. All of this is part of the Docker file. But before we write that, I want to remind you of something that I showed you earlier in this video, which is that when we go to an image like Ollama, for example, we see the layers. And the layers are basically individual commands for a Docker file. So I can use the full screen here. You can see we have stuff like add, command, env, run. These are commands that we're going to use in the Docker file. And you can also see that the Ollama web UI image here is based on Python. And you can see here the from command. So Python is based on Debian, which means there is an image, a base image, that is a Debian installation, essentially, a slim Debian installation. Now, Python is running on that. So Python takes that, installs Python, and now we have a new image. And then Ollama takes the Python image, does some additional stuff down here, and then we have a new Ollama image. And we're going to do something similar for our application here. We're going to start with from Python colon 3-12 or 3.12-slim. So this is going to take the image Python 3.12 slim as a basis. So this is going to be the base image, and now everything else is in addition to what has been done to create the Python image. So you could say it's incremental. And the first thing we want to do is we want to define a working directory. It's going to just be /app. And then we're going to copy the requirements.txt file. So I'm going to say here, copy requirements.txt from my system to the working directory app, and then run the following command. Run pip3 install -r, or actually, first of all, -- no cache dir, since we're working in a container, -r requirements.txt. And then we're going to copy all of the other stuff. So from here to here, so from the local directory where the Docker file is to the app directory, which is the working directory. Then we're going to write expose port 5000. Now, this doesn't really have an effect. It's more like metadata for the user to know that this port is relevant and has to be exposed, but it doesn't really have an effect. We still need to expose the port manually when running the container. So we need to provide the p tag, which we're going to take a look at in a second. And then I'm going to define the environment variables here. So I'm going to say debug equals false with the env keyword. So debug false, port is equal to 5000, even though that's the default. Maybe it makes sense to do it explicitly. And then log file is going to be equal to /data /logs and then logs.txt. So we have a custom path here. And then finally, we want to specify the command that shall be executed once the container is being run. And for that, we're going to define cmd. We're going to use square brackets, and we're going to say Python 3, and then just app.py. So that's our command. Of course, you can also use Unicorn or Gunicorn. I'm not sure how this is pronounced. You can use UVcorn and all these different servers, but you can also just do Python 3 app.py and use run. Not the best way for production, or not the best strategy for production, but it does work. So that is our Docker file. Again, what does this mean? We take this as a base image. We have the image that is a Debian image that has Python installed. We take that as a basis. There we define the directory, the working directory, to be /app. We copy our requirements.txt file there. We run the installation command. We copy the rest of the code. We expose port 5000, which is mainly for documentation. We set 3 environment variables. And once the container is being executed, we're going to just say Python 3 app.py. This is going to start our server. Now, all we need to do to turn this into a Docker image is we need to say docker build-t, and now we can specify a name and a tag. So let's say, for example, Flask application, and then maybe :test, just so we have some tag, some version number, so to say, or some specifier. And then I'm going to use dot to say the current directory. So take the Docker file from this current directory as a basis. I can run this, and what happens now is you can see all of this is being executed. Asks me for the password again, and now we have our image created. Now I can also take a look at my Docker desktop. I can go to the images here, and you can see we have the Flask application image. So all I have to do to now run this is I have to say docker run -p. This now exposes the port. So what we do is we say we want to export the port 5000 to the port 5000. So I want to say 5000, 5000, and then Flask application test, and then we can also do a -rm to get rid of the container once no longer needed. But now basically I can click on here again and I have the same thing running, even though it's not running really on my system. It's running in a Docker container. I'm just exposing the port, so I'm just mapping the port 5000 to the port 5000 so I can use it here as well. But this is now fully running in Docker. I can uninstall any Python version I have on my system. I can uninstall all the packages. I don't need Flask install anything. This is running now purely in Docker in the container. So I can take this now, and if I have the image, if I push it to Docker Hub, go to a laptop where there's no Python installed, but I have Docker installed there, then I can pull the image and I can run the container, and I'm going to be able to use this Flask application even though I don't have Python installed. So this is the basic way to work with Dockerfiles. Now, we're not going to be able to cover everything in this crash course today, but I would like to give you an example of using Docker Compose to make multiple containers work together as a single application. So we have a backend, we have a front end, we have a database, each running in their own Docker container. And with Docker Compose, we can easily make them work together as a single application. Now for this, I have prepared a simple example. The shopping list application, here we have a backend and a front end. The backend is a fast API backend. The front end is a simple React front end. And the database is a Postgres database, which is of course not part of this directory now. So let us briefly take a look at the code just superficially. By the way, you can find all the code at the link in the description down below. I'm going to provide a link to my GitHub where you're going to find the code if you want to take a closer look. Now we're going to just skim through it to see what it's about. It's just a basic fast API backend with some middleware to allow for requests from the front end. We have this database connection here where we have host equal to DB, database equal to shopping, user and password equal to Postgres. This is important. And besides that, we just have basic endpoints for creating items and deleting items. Nothing too complicated, nothing too interesting. And we have already a Docker file in here where we do what we just did before. From Python, work your app, copy the requirements.txt file, run the installation, copy the main file, expose port 8000 as a documentation here again. And then the command is not Python 3 main py, it's uvcorn, because this is how we run fast API backends. Uvcorn main app --host 0000 port 8000. That's basically it. This is a Docker file for the backend. Now for the front end, we can go, actually I went one level up. So in the front end, we also have a Docker file. We can take a look at the source code here at the app.tsx file, which is the most important one. Here we basically just send requests to the backend, nothing too interesting. We just, use the backend. So very, very simple, very minimalistic. And here we also have a Docker file, which you can also, by the way, find on GitHub. Again, we just use another image here as base, a node image. We define a working directory, we copy the packages, we run the npm command, we copy the rest of the stuff, then we build, then we use another image here as a baseline, we use nginx as a reverse proxy, and we run the front end. So that's basically what we do here. And we also have a file .env, and this .env file, actually I need to do neovim.env, has this simple vite API URL set to localhost 8000, so we know what we're targeting here. But that's basically it. And now we're going to write a simple Docker Compose file, which is going to make all of this work together. So I'm going to go one level up here in the shopping list app, and I'm going to create a file called docker-compose.yaml, so YML. And here now we're going to define our services. We're also going to define our volumes, and we're going to set this up as one application that uses 3 containers or 3 services. So we're going to start by saying services. Maybe let me zoom in a little bit here. services, and the first service is going to be the database, because the backend is going to depend on the database and the front end is going to depend on the backend. So we're going to say here DB, and we want to use here the image Postgres 14 for our database. Now, this is an image which is going to be pulled from Docker Hub. This is not our image. We don't create this. We don't have a Docker file for it. This is something we pull from the registry and we just use and configure, or configure and use. So what I'm going to do here is I'm going to say environment to set up certain things. The first thing is Postgres underscore DB is going to be equal to shopping. This is the name of the database that we also specified in the backend. Postgres user is going to be equal to Postgres, and Postgres password is going to be equal to Postgres as well. And in order to keep the database persistent, so to actually have the same database and to also save the updates whenever we run a new instance, whenever we run a new container, even if we delete the container, we need to add a volume here. So we're going to say volumes, and we're going to say pg data, and then var lib postgresql / data. So basically what this means is we're going to use the pg data volume, which is going to be created automatically. We're going to map this, or we're going to mount it to var lib postgres data in order to get the data here into the volume to load it back whenever we run a new container. That's just basically making sure that the database content is preserved across containers, or across sessions, we could say. So that is the database. Then we're going to define the backend. The backend is going to be built by going into the backend directory, so /backend, like this. We're going to also specify an image here, but this image is not for pulling from Docker Hub, it's for pushing to Docker Hub, because what we're going to do here once this works is we're going to push that to Docker Hub so you guys at home can pull it from Docker Hub and play around with it. I'm going to push it publicly, so all you have to do then in the end is you just have to pull it from Docker Hub, you have to run it, and no setup needed. If you have Docker, it's going to work. So the image I'm going to choose here is neural9, my username on Docker Hub, and / I don't know, tutorial backend. So image neural9 tutorial backend. This is important for the push. The ports that we're going to use here, so the port mapping is going to be 8000 mapped to 8000. Now this is not just documentation, this is actual port mapping now. So this is not like exposed in the Docker file, this is actually doing the port mapping. So this is important. Then we also specify depends on. The backend depends on the database. So here we're going to provide -db. And then we're going to also say here logs, since in the backend we do some logging, just so we have a second volume here. Logs, the Docker volume logs is going to be mapped to app logs in the container. That is the backend. And then finally, the front end is going to be built by using the Docker file in /frontend or ./frontend. The image here is again going to be relevant for pushing. It's going to be neural9 tutorial frontend, and then ports is going to be, in this case, port 80 is going to be mapped to port 80. This is because we have Nginx running at port 80. And then finally we say depends on backend, and thus also on the database. So we have the database, which is going to be pulled from Docker Hub. It's going to be set up with these parameters here. We're going to have this volume here to persist the database content. Then we're going to have the backend. The backend is being built by using the Docker file in backend. We're going to define the image name tutorial backend here for the user neural9. I'm going to push that later on. We're going to map port 8000 to port 8000. This depends on the database. We have a volume for the logs, and the front end is going to do the same thing here with the Docker file in front end. Has a different image tag or a different image name. Port 80 is being exposed, and it depends on the backend. And finally, all we have to do here is we have to say that we want to define two volumes. The two volumes are going to be logs and pg data. that is now our Docker Compose YAML file. So I'm going to close that. And all we need to do now is we need to do Docker Compose up. So I can enter my password, and this should then pull the database. Okay, so in my case, it says that port 80 is already being used. I think this is because I have Apache running. So system ctl stop Apache service. Then I should be able to stop that service, and then I should be able to do this again. And now we have the front end running. We have everything running. Let's open up the browser and see if we can actually reach that. So here I'm at a localhost port 80. I can try to add something. There you go. Add, delete, delete. And now I can close this. I can terminate this. I can do Docker Compose down. And then this everything, so all the containers are going to be removed. I can do Docker Compose up again. I can go to my localhost again here. So actually now this is in a different workspace. So let's do it here again. Basically, I still have the content from before. You can see this has been persisted. So I can open up the dashboard of Docker Desktop here again. We can see I have a container, or actually I have multiple containers. I have this aggregation here where I have the 3 containers, front-end 1, back-end 1, and DB1 running, port 80, port 8000, and these are running together. These are interacting. I also have the volumes. I have now shopping list app PG data, shopping list app logs, and these are in use. They are used by the respective containers. So this works pretty well, and all you guys would have to do now is you would just have to go use this Docker Compose YAML. I think you literally can copy this Docker Compose YAML and nothing else from my GitHub. So again, this file here, and all you have to do is you have to say Docker Compose, or Docker Compose pull, I think. Yeah, Docker Compose pull. This is going to pull the image once I uploaded this, of course, because now it's not yet on Docker Hub. Now this is not published yet. But once I publish this, you will be able to just do Docker Compose pull, Docker Compose up, and this is going to show you, this is going to run the application you just saw without any problems, without you having to bother to set up any dependencies or configurations. So how do we actually push this now to Docker Hub? All we need to do is we need to say Docker Compose build. This is going to build everything that we need for pushing this. Then we're going to have to authenticate ourselves. So we're going to say Docker login. In my case now, this is going to already succeed because I have my credentials. Otherwise, you're going to have to authenticate yourself. And then all I have to do is Docker Compose push. This is going to push it to Docker Hub. As you can see, everything is being uploaded. And the only thing you need to do now, if you want to see if this works on your system out of the box, is install Docker, copy or type the Docker Compose file, and then just do Docker Compose pull, Docker Compose up. And you're going to have the application running on your port 80, and you're going to be able to add and remove entries. So that's it for this video today. I tried to cover as much content as possible in as little time as possible. Because of that, we only briefly touched on a couple of concepts. So this is not an in-depth course, of course. I would recommend that if you're interested in Docker, you go and read the documentation, you take a proper tutorial that teaches you Docker for multiple hours. This was a crash course to give you a big picture understanding so you understand what Docker is about, how it basically works, how you can create images, how you can pull images, how you can also use Docker Compose. Now you have a basic idea, and now you can learn more about this and go into more details. So if you like videos like this one, please let me know by hitting the like button and leaving a comment in the comment section down below. Also, of course, by subscribing to this channel and hitting the notification bell. It helps the channel, it helps grow the channel, and it makes more videos like this one possible in the future for free. Besides that, thank you very much for watching. See you in the next video, and bye.